Hello class. Today we are continuing our discussion on waves. In this particular lesson we are going to focus more on the behavior of waves. Look at the pictures that are shown here on this slide. And I want you to just think for a moment, how do you think these pictures relate to waves? If you can't come up with any ideas of how these pictures relate to waves, I want you to pay attention to when you see these pictures in the slides, and you'll be able to then make that connection between these pictures shown here and what in the world do they have to do with wave behavior. Let's first look at our learning target and our standard. Our standard, we're still on SAP 4. Students will explore the wave nature of sound and electromagnetic radiation. We are now looking at standard B today. Describe how the behavior of light waves is manipulated, causing reflection, refraction, diffraction, and absorption. We have two learning targets here that you need to make sure you add to your student-friendly standards in your notebook. Learning target 1, I can describe the behavior of light waves such as reflection, refraction, diffraction, and absorption. I can observe different examples of wave behavior and classify them as reflection, refraction, or diffraction. So those are our learning targets that we want to be able to accomplish within these lessons on wave behavior. Let's first talk about reflection. Reflection occurs when a wave strikes an object or surface and bounces off of that surface. We are all familiar with being able to see our reflection in the mirror, but you may not have thought about what does this have to do with waves or even science for that matter. Well, reflection happens because of these waves that are hitting a surface and they're bouncing back off of that surface, which causes you to be able to see your reflection. Light waves produced by a source of light such as the sun or a light bulb bounce off your face, strike the mirror, and reflect back to your eyes. Sound waves are also reflected whenever an echo occurs. So sound waves can also have this particular characteristic as well. Refraction. Now refraction may be one that you may not be that familiar with, but you probably have seen refraction on several occasions. Refraction is the bending of a wave as it moves from one medium into another medium. Now we all know that waves travel through a medium. And when waves move from one medium to another, their speed will change. And when their speed changes, this is what causes an object to, or causes refraction to occur. You've probably all experienced this phenomena before. If you placed a pencil or even a straw into a glass and you look at that glass from a certain angle, it looks as if that object is broken in half. Well, we actually know it's not broken in half. If you pull it out, it is a whole piece. But it looks that way because right here where the object appears to be broken, that is when the light wave is changing its speed as it's moving from one medium to another, which would be from air, which is above the water, and down into a liquid. So that is what happens there. Now over here, this kind of shows you a little bit more in detail what's happening. I have air here and I have water here. And right here, as that light wave is changing its medium, it starts to bend, which causes the pencil or the straw to appear to be broken. A lot of times with refraction, we may see things as they really aren't. It's what we would call an optical illusion. This is another example here of refraction. If you've ever looked at an object that's inside of water, for example, like if you've ever looked inside of a fish bowl, and you may see the fish here. This is where your eyes may think the image is located, but then actually this is where the image actually is. This is the actual position. This is what we would call refraction. Or maybe if you've ever reached your hand down into some water to get something, and you reach in one spot, but that's not where the object actually is. It's actually maybe a few inches over from where you actually are reaching for it. That is caused by refraction, and that is just light waves bending as they go from one medium to another. Diffraction. Now diffraction and refraction sound alike, and they actually have some similarities. Diffraction is the bending of waves around a barrier. So they both involve the bending of waves, but bending in different situations. Diffraction is going to occur, or a wave will diffract depending on its wavelength and the size of the barrier or the opening that the wave is trying to go through. Light waves have a very small wavelength, so therefore they're not going to bend that much, especially around larger obstacles, such as buildings. However, sound waves can. Think about if you're in a room, a lot of times you will hear a person coming before you can see them. That's because the sound waves are going to have a longer wavelength and they can bend much easier around large obstacles than a light wave can, which is why we tend to hear people coming before we can actually see them. This is an example of diffraction here. You've got the waves coming, and as they're trying to go through this barrier, they will bend. And of course, like we said, how much they bend will depend on their wavelength and the size of the barrier that they're trying to go through. This could also be an example of diffraction here, light diffraction through clouds. When you can see little bits of light peeking from around the clouds, that would be an example of light waves diffracting. Another example is if you're in a dark room, for example, and there's some type of opening around your doorway, you can still see inside. You can still have light in the room because that light is going to bend around that barrier. Absorption. Absorption is the final type of wave behavior that we're going to discuss. And absorption is a little bit different from the other three types of wave behavior. There's kind of a lot going on here with absorption. Well, when you think about the word absorption, you probably think about something being taken in. For example, heat. Objects may absorb heat. That's pretty much what we're talking about with absorption. Absorption is the transfer of light energy to matter. Some light waves can also be reflected or transmitted. And that's kind of where we get into the whole conversation about how our eyes can see different colors. The color of an object is determined by the wavelengths of light that it absorbs and those it reflects. We've talked about the visible light spectrum, or we've seen it. It is visible light, remember, is an electromagnetic wave. And on this particular spectrum, we have a part of it called visible light, which consists of all the colors of the rainbow, which are the colors that we are able to see. That's why it's called visible light. Well, the fact that some colors can be absorbed by an object or reflected by that object depends upon the color that you see. For example, look at this picture here. A red apple will absorb all of these colors of light except red. Red is the one color that would be reflected, which is why our eyes see this object as being red. A banana, for example, is typically yellow in color. So that means all of these colors would be absorbed by that banana except the color yellow. Yellow would be reflected, which is the color that our eyes would see. Now we're going to talk more in detail about absorption and why our eyes see the colors that we see in our next lesson. So just know for now that absorption can occur when light energy is transferred to matter, and that also that energy can be reflected, which we talked about earlier, or it could also be transmitted, which just means that it can pass through an object. Look at this particular slide. This is a quick wave behavior review over what you have seen in this lesson. Go through these particular examples and just see how many of these that you can figure out. And then on the next slide that we're going to show you would be the answers. So go ahead and pause your video here and then see if you can figure out what these 4 examples would be. And then go to the final slide to determine your answers. Okay, these are the answers here on this particular slide. Look over these. If there are some that you have a question about or maybe you don't understand, then make sure you write that down and ask me in class. That it concludes this lesson on wave behavior. Make sure that you have completed your graphic organizer, that it also includes examples of pictures, and make sure you have written down any questions that you may have about anything that you heard or saw in this video. Okay.